This application is really the premier. Again, what's kinetic energy? It's velocity and mass. It's more about harvesting energy that would otherwise be wasted with braking. And so, of course, we've got the bulk of that in traffic.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about kinetic energy, taking a little piece of the motion in our daily lives and harnessing it for some serious wattage. The solution our guest has devised is so obvious you'll wonder if you thought of it yourself at one point. Yep, he's found a way to turn traffic into energy. By placing specially designed units on the road, the motion of the tires moving over them will generate electricity. Oh yeah, turn it up! We're talking serious power here. One car can generate a kilowatt traveling at just 5 miles an hour. The energy potential is a function of speed and mass, so if a semi-truck were driving at highway speeds, the number I've been given is almost too good to report. For now, they're focusing on slower velocities, heavily congested rush hour, exit ramps on interstates, entrances at parking garages, things like that. Plus, rolling over these units at high speeds may force the vehicle to ramp, but a future iteration of this design should be able to solve that. I'm told there are other competing designs out there, but they typically resemble a speed bump, which would definitely not work at high speeds. This one takes its cues from a rumble strip. You've probably heard of those rumble strips out west that make music when you drive over them. Maybe one day it'll be making energy as well. Our guest today is Jim Nigg, President and CEO of Constructis, a South Carolina-based startup located near Greenville. Jim was an infrastructure expert at Fluor and served in the Navy before that. The company was founded in 2015 in Jim's garage and is now split between the Greenville location and San Diego. They're calling their unit the Roadway Energy X Platform, or REX, and it's looking like Constructis is ready to begin commercial operations at almost any time. This was rare for me these days, but I couldn't pass up a chance to drive down from Charlotte and meet Jim in person. I hope you enjoy my conversation with Jim Nigg. We're here with Jim Nigg, president of Constructis. How did you get this idea for what you're calling the Roadway Energy Sensor System? How did you get that idea?
Yeah, well, Jay, I appreciate you having me. We've actually modified the name now. We're calling it the REX, the Roadway Energy X Platform. The genesis of this was in the early 90s when I worked for Washington State Department of Transportation. I'm a civil tech grad. And we did some of the nation's first EPDM bridge joints, expansion joints. And after about 6 months of installations, my boss sent me out there to do a review on them. And the concept popped in there, how much energy was hammering on those joints every day. Hundreds of thousands of vehicles a day.
So we're looking at the design right here. It looks kind of like a grate, and then it's got some movable parts in between, and they kind of create the bumps. Is that what those joints on the bridges look like?
Yeah, they're a polymer elastomeric membrane that connects the bridge structure to the roadway. And so that's the original concept of this, is simply a rumble strip type. And the advancement went from one system to multiple, to where these tubular shaped structures depress when a vehicle passes over them. We capture that impact energy, or motion and mass, and we convert that to rotational energy. We temporarily store that energy in battery banks within the box, in the ground, and then we operate sensor systems and net meter the excess. The sensor systems can provide weights, measures, traffic identification, volume, pavement operations, so it's pretty expansive on the direction we're heading.
And how much energy density are we talking here? One of the things that was fun, especially when I did the hydroelectric, was this 100-year-old powerhouse was 120 megawatts. So start us off here. How much power can a single car produce rolling over your sensors? And how do you plan on daisy chaining these on, say, like a major interstate or something?
Yeah, sure. That's the meat and potatoes of what we're doing. The system right now, we're averaging a little over 1,100 watts per car pass, or 2 axles. And the total right now calculated out is, of course, based on traffic volume. So we've targeted 100,000 vehicles a day traffic, which is your basic 2-lane each way busy roadway. And with that type of volume, we're harvesting approximately 79 kilowatt hours a day. And that's pretty exciting stuff. Then what do we do with it? And that, of course, will be up to our prospective clients on whether they want it dropped into the grid and at what time we can meter that drop, or operate systems for, say, parking garages or other applications.
So essentially, one car would be about a kilowatt, right? Is that the idea?
Yeah.
Okay, so
and it's for 2 seconds on the time.
Okay.
So right now our timeline is 2 seconds, which we actually expect to double that if things go well on our new modifications. 2.73 family homes,
right,
powered in perpetuity, right?
Okay.
At the 900 kilowatt hours a month average.
Yeah, I'm curious about the design and how that works. So could you produce more power if the vehicle is heavier rolling across it, or say a faster vehicle is running across? How does weight and speed help with the power you're getting out of each of these strips?
Yeah, the answer is yes, Jay. We've got application designs for the heavier mass vehicles, looking at ports and military loads as examples, as well as volume. And there's also other applications for speed, meaning higher speed, higher velocity. Right now, this prototype is for the slower speeds.
I'm sorry, what's a slower speed?
Right now, we're 5 miles and under. We've done speeds at 28 miles an hour. And what we're finding is that we need to space out the rumble strip application so that we don't get a wheel hop in there.
Gotcha.
And the other discovery we've made with the kinetic energy harvesting, again, is that the speed of these vehicles impacting it, it'll actually hydroplane over it. And the feel is actually softer than a rumble strip. Some of our rural roads where you'll drive across a rumble strip and it'll wake you up to a stop sign coming up.
That's right, they kind of make a tone, right?
Right.
Yeah.
These are softer because they depress.
The 5 miles an hour is going, well, what if it's rush hour and these cars are creeping along? It's like that would almost be ideal, you know, in a way. But you say you're also kind of working to get up to when people are going much faster. Because I'm imagining some of those really busy highways in like Atlanta and LA, all these kind of places. You know, you spend a lot of time out in California. That's ideally what you're thinking about is the theater, right?
It is, where we've got 200,000 vehicles plus. And it's notable that in those rush hour timelines, you're on the highway doing less than 25 miles an hour. But our applications for those type of areas will install higher speed applications, and also to have the ability to retract the systems for off-peak hours, where it makes sense for the high volume capture, but not everybody wants to drive over these things in off-peak.
Gotcha.
They're going to pick up the speed.
Yeah. I ride a motorcycle. One of the things that you hate, so what's it like if you're riding a motorcycle?
We've got skid-resistant coatings on the system. They're tubular shaped, and they're designed for those type of impacts. I'm a rider too, and actually tested this.
Yep.
It's also notable that the resistance on the kinetic energy calcs, while we can increase it for different applications, what I've shared with the engineering team is that it's not the maximum that we can achieve or harvest from that vehicle. The peak is actually going to be when Mrs. Smith spills her coffee in her car driving over them. So there's a nuisance factor there that we're aware of. If they're not amicable to everyday driving and applications, it won't work.
Yeah.
And so what we see with this application in a bigger picture is that this application is really the premier. Again, what's kinetic energy? It's velocity and mass.
Yeah.
And so, of course, we've got the bulk of that in traffic. We see them not so much on the interstates, although we do see that happening, but moreover on, say, off-ramps where vehicles are slowing down. We'll help them slow down. Parking garages, parking lots, ports, borders, bases, those type of applications, as well as large parking facilities for major businesses where we can support those clean energy goals as well. And we tie right into some of our other clean tech operations out there with solar and wind and some of the others.
We've talked about this offline. You're on one of the latest of several iterations of this concept. Tell us how it's evolved.
Yeah.
And how long have you been working on this?
I got to take a deep breath on this one. I've been working on this full time for 3 years. And so kicking this off was really a big passion. It started in my garage, literally. As it evolved, I started hiring folks smarter than me to help develop it. And the final cusp, if you will, was a PhD that I hired who said it wouldn't work. And that's exactly why I hired him. And he came back 6 months later with computer modeling and my original schematics and, of course, what I called Frankenstein in the garage, and said, hey, this thing's going to work.
I love it how he said this won't work. And then I can just imagine him coming back about 2 or 3 days later with drawings and stuff going, oh, but I think I figured it out. You know, he said it won't work, and it sounded probably like that was the end of it. And then is that how it worked? He basically came back to you and said, but if we did this, is that kind of what happened there?
Close. It was probably over 4 months and 20 grand worth of efforts, but it is what occurred. We can do math all day long, but when you can see something, it's a whole different story.
You're using a battery, but is that necessary? Can you be supplying energy straight to the grid and metering it? Why the need to do a battery first?
Sure. The straight answer is yeah, we can certainly direct meter our system, similar to solar for residential. However, some of the problems that you see coast to coast is to maintain that grid parity. So it became necessary to look at that temporary storage or even long term.
So it would store the energy in a battery and then trickle it out in more of a steady stream? Is that the idea?
We can do both. Some want that steady stream of output. Others may want it at a specific time period during peak usage or off-peak even. For us, it's more about harvesting energy that would otherwise be wasted with braking.
What's your economic model here? Would Constructis still own them and they would rent or find a way to get them into the roads and you would make money off of the power? Would you just be selling kit? What do you think is going to be the way you ultimately go with this?
We see both business models, if you will. Some of the clients that we've been talking to, they don't want any involvement in the maintenance of the systems. They're not interested in anything other than the power. Others want to own the system. We see the ability to do installations at zero cost in exchange for power. So 70% power coming back to Constructis, 30% going to that owner. It makes sense on those type of applications too.
You know, I'm always a big fan of the idea where you're able to always have a steady stream still coming in rather than you sell your widget and you get a profit off of it. I assume a lot of your investors are probably interested in that too.
Yeah,
they kind of want that.
Yeah, it is amazing the various applications that we have. And again, some large manufacturers, they've got more interest in the clean energy bragging rights, which is pretty amazing to me.
What do you see as the ideal application? You've mentioned a lot of different things. Off-ramps at interstates, I'd imagine 12 lanes spread across thousands of cars. So what do you see as the low-hanging fruit here?
Several. The DOT applications will be a little further out for us, but initially I see it certainly as private installations, large businesses, parking garages. Those are large volume applications. Certainly for the borders, hundreds of thousands of vehicles a day, where we can also support the screening of those vehicles and expedite traffic flow.
Yeah, I like that.
Yeah, the commerce numbers just on that one application are pretty extreme.
Even if you're doing things like parking garages and stuff, you still think that's enough volume to make enough juice for it to be worth the squeeze, huh?
Yeah, I do. Right now, our ROI on a 25-year power provider agreement is right around 11 years. As this continues to be refined, we see this technology applications really all over, not just in the United States, but globally, especially
pretty much anywhere where there's something that rolls, right?
That's right.
Yeah. And you basically tie into the grid, I assume through the distribution, just right up a pole.
Yeah, we would have the local utilities do what's called a power pole drop, and they would just send out a crew, put a meter in off that pole, and we would tie our equipment up to that. It would be just a net meter type of drop, and we would hook straight up into it.
You've been on the road a whole lot. Where have your travels taken you?
Sure. Well, coming back from California here to South Carolina, besides meetings here locally, up to Boston, it also included meeting with some really key vendors, partners, as long as strategic vendors, and also met with TARDEC, which is a part of RDCOM, or Research Development Engineering Command, which is the R&D arm of the military. Mm-hmm. And they're out of Detroit. And I was really excited about that invitation up there. Being a former military individual, they're huge in innovation and advancement. And it's exciting to say that we have some direct applications with the new bridge launch. It's a scissor bridge that we use to set over ravines and such. And so we're excited about bringing some energy into these types of bridges. Some of them that were set back in World War II that continue to be used by small towns are rusted out. And so with an energy device within those bridge systems, we'll be able to monitor longevity and the health of the bridge.
I think I remember that bridge launch toy on G.I. Joe from years ago.
Yeah.
I came from oil field. One of the things that was always the most important deal was make it tough, make it where you have guys out there who could, as one of my coworkers used to say, could break an anvil, and this looks pretty tough. So tell us a little bit about what you've done to help strengthen it up, and especially when you start putting the mileage, if you will, on it and everything. Sure. And it's got to be resistive to the environmental stuff. Wind, the rain, the snow, will water short it out? I'm sure there was a lot to get through to overcome a lot of that toughness.
Yeah, what we have is a structural integrity that can hold over 80,000 pounds per axle load.
And by the way, a semi-truck has to top out essentially at 80,000 pounds.
That's right.
So you're talking about an 18-wheeler with 9 axles on it. So
and we can do that per axle.
Per axle. That's pretty wild.
Right.
Yeah.
So we've overbuilt it. Right now, what we've touted is 3-season climate resiliency. Sorry, we can't do anything about snow and ice buildup.
It'd be tough enough just to thaw out later, right?
Yeah,
okay.
It sure is.
Okay.
Within the box, we've got the ability to heat, cool, and insulate those systems to where they really are viable anywhere in the world, save maybe the North Pole, Alaska, Antarctic.
Yeah. When I'm thinking about rush hour, I'm thinking about these things being active during those times, especially evening rush hour.
Sure.
That really tracks the energy demand curve. I'm told that there's this peak energy demand during what would be evening rush hour, sun's going down, people coming home. Seems like you're supplying power during a critical time of the day. So you said you've kind of been told that and kind of flirted with that idea of being able to supply power during peak demand. So how does that really fit into your plans for this model?
It works out well. Mm-hmm. Again, we see the need for the battery storage, which it's notable that right now we've got designs and vendor selection process. I'd love to hear from interested battery suppliers for that storage, where per lane we can exceed 120 kilowatt hours of storage, which is just amazing. So 4-lane application, we're pushing 480 kilowatt hours of storage.
You said the PPA had you at a payback of 11 years?
11 years.
And we talked a little bit about how robust it needs to be, and parts do wear out and everything. So tell us a little bit about the O&M issue and how you hope to improve upon that.
Yeah, constant challenge for every energy producer, certainly. We see us comparable with the other energy sources. Certainly, we'll have sensor systems. If anything wearing excessively or broken down, we'll send teams out there to repair them at night. Again, least amount of traffic. Quick note on the installation of them is that we can install these in 4 to 6 hours, several units per lane. So that's a fast install. We've compartmentalized the subcomponents within the system to where we'll literally open the box up, pull these systems out, drop another one, and plug it in. And so it's really a key reason why we're market viable, is because we've actually achieved what nobody else could. There is some similar systems in Europe, but the speed bump is what they have. Nobody's ever done the rumble strip. It's exciting to have these patents on this product moving forward.
You had an interesting comment. I can relate to this one. I've dealt with a few startup situations before, but you said true innovation has no friends. And so what I think you're meaning by that is that no one's willing to pony up the dollars until it's almost done. I mean, I don't think that any venture capital guy would put money in the wheel until it was actually proven. Take us through that road. I know that must have been challenging. It's like, look, here it is. We got results. What really got the dollars to flow?
I think the straight answer is that right now they're still investing in the idea and Jim Nig. These are fellow executives and business professionals coast to coast that continue to help out. And it wouldn't happen without them. And when you relate to the large, say, grant programs, SBIRs particularly, there's huge dollars that are so focused and so targeted, there's no other category. We don't fit in any of these. But they're so targeted, they're not interested in us.
You know, there's so many great ideas out there. I think a lot of folks make it sound like that money's available, but there's a lot of hoops. So what do you think, as an entrepreneur with a really innovative idea here, what do you think would help that along for folks who are out there?
I think even today and historically, it's still about the government support for these type of funds. Again, the investor community, unless there's a precedent that they can compare to, they're not interested. Or certainly at a specific milestone, which is where we're at now. Now we're starting to get a lot of attention because of the product output, the market viability, et cetera. And it's the same with the banking community. Again, no precedent. I sat across the desk of one individual who said it would be easier to get $250,000 to open a bagel shop. And I had to ask him, and he said, look, we would know what the typical business revenue is, where you would want to put it, and the volume of people that would swing in to buy a bagel.
What could we do out there so that people who have money who want to invest in these things are a little bit more shielded or would feel more open to investing in things like that? You think there's any solution to that? Or
I've been chewing on it, mostly because, again, any open door I've gone into, and I've found that they all, banking communities, investors, whether you say VCs or angels, all look for a precedent.
I'm going to finish up with a lightning round of your thoughts on different energy technologies. Natural gas.
A powerhouse provider, impressive technology in the turbines, concerned about the overall emissions.
Crude oil.
Key product that is crucial, if not more, in other products.
Nuclear.
Another powerhouse in advancement, impressive small nuclear reactor designs that are moving forward. However, I think our biggest challenge globally is what are we doing with the waste?
I like those SMRs too. Coal.
We've got obviously one of the largest coal reserves in the world. Let's utilize it. Impressive technology on the secondary scrubbers and see that advancing to where it really is putting out reasonable emissions that we can tolerate.
Wind.
More impressive technology regarding turbines. We've got some environmental challenges, surprisingly a little noisy, but impressive technology that I see continuing.
Solar.
Keep going. They've got challenges regarding coatings, some of the wear with the sand and grit and weather-wise, but certainly a key alternative energy source for the world.
Biofuels.
Equally impressive, however, don't necessarily agree with the food products being focused for fuel.
Hydroelectric.
That's our standard. Certainly the global standard for cost to output. The challenges remain on environmental protection, but we've made a lot of headways in protective measures.
Geothermal.
One of the fastest advancing energy sources out there, just look at Iceland, right? They're growing bananas out there. Amazing technology that will certainly advance.
Electric vehicles.
Exciting to share right where we are here, and of course, that is the destiny. And one where we see our own applications in induction charging to support those vehicles, as well as electrical charging stations where we can install our systems on the road to help support powering those vehicles.
Oh, so you think that you would also be able to wirelessly charge as they're driving across?
It's a brass ring, buddy. It's a brass ring.
That's pretty wild. wild. Oh, and then while we're on the subject of vehicles, I'm always trying to figure out where do you fit in this mix. And I think in the subgroup under electric vehicles, because it's automotive and all that. So let's do you guys. What about your kinetic energy?
We hope that with the support as we continue to progress, we get these initial installations in, and as we grow this year, we hope that the federal government will recognize kinetic energy as an alternative energy source. What I see the future is energy efficient homes, where we'll see thresholds, door hinges, and things along those lines that harvest the energy from that motion and put it back into the house.
And speaking of homes, energy efficiency.
The average home puts it on as 900 kilowatt hours a year average per family household. We have to become more efficient. I mean, it's just an absolute requirement.
And then finally, nuclear fusion.
Amazing stuff. I'm certainly a science advocate and not sure where that technology will go, but it's exciting to see them move forward on it.
Okay. Jim Nigg, Constructis, thank you so much for your time.
Yes, sir. Thanks, Jay.
That was Jim Nigg, President and CEO of Constructis, a South Carolina-based startup specializing in making energy from traffic. I really appreciated Jim giving me some time to come down and visit him at his offices located at the Center for Manufacturing Innovation at Greenville Technical College. We've got a great pick together on the research floor. As you can tell, Jim and I spent a lot of time talking about the challenges of securing funding for original ideas like his. And one avenue was the university sector. But one of the biggest catches working that route is that schools typically want a huge piece of the intellectual property. Luckily, Jim has found a suitable partner in Northeastern University and the Global Resiliency Institute, who is offering them PhD validation. Just one more step in the process for them. You can find plenty of pics on the company's Rex platform on Instagram at Host Energy and online at energy-cast.com. All guests are sent the raw and completed shows the week of release. So far, no complaints. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 36. Be sure to join us next time when we meet a pioneer in geothermal energy who's found a way to produce more than just electricity. You won't want to miss it. Until then, I'm Jay Downhauer. We'll see you next time.